Hello everyone. In this session, I'm going to discuss about what is transpose of matrix, what are the properties it is having, and some examples related to transpose of matrices. Okay, let us dive into the solution. What is transpose of matrix? Well, you can see here, if a matrix with m by n order, the matrix obtained by interchanging the rows and columns. Interchanging the rows and columns, that particular matrix is known as transpose of a matrix. Okay, and it is denoted with a dash or a power t. That we'll read as a transpose. A is transposed, means we have written already the rows as columns or the columns as rows. And you can see one example. Let us take one 2 by 2 matrix 2, 3, 5, 6. For this particular matrix, what is transpose matrix? A transpose will be like this: 2, 5, 3, 6. What is changed here? Here it is a column that we have written as a row. The second column we have written as second. This is how we will transpose a 2 by 2 matrix. You can see one example predefined here. It is 3, 5, root 3, 1, 0, minus 1 by 5. This is A. We can write it as A dash, we can write as the row, the column will become row. 3, root 3, 0, 5, 1, minus 1 by 5. This is A transpose. That's it. Nothing much is there about it. Just understand what is the basic definition, how to find out the transpose of a matrix. Then what are the properties these holds? A transpose, all transpose is A. Suppose you have a matrix 1, 2, 3, 4, 5, 6. If you find out transpose for this, what you will get? 1, 2, 3, 4, 5, 6. Okay, this is A transpose. For the this particular transposed matrix, again find out transpose, full transpose, which is nothing but again we get 1, 2, 3, 4, 5, 6 only. That's why they are telling A transpose, whole transpose is A. And multiplication with the scalar, K A whole dash is nothing but K A dash. Just multiply with a number, that is so easy, I think. Take one example and multiply. A plus B whole dash is A dash plus B dash. AB whole dash is, this is very important. We know that matrix multiplication is not commutative, so we should be careful. AB whole dash is nothing but B dash A dash. We should start from the second matrix, B dash A dash. These are the very basic properties of the transpose of a matrix. Let us see. One more definition: symmetric and skew symmetric. The meaning itself, it is symmetric means you just take the diagonal elements, whatever you have above and the below, whatever you have above and the below, whatever you have above and the below, they must and should be same. Then only it is called as symmetric. Okay, this is a very basic thing. Like you can visualize it. Whatever you have here and here, they must and should be same. Then you can call it as symmetric. How can you define? How can you define is very important. If A transpose is A, if you interchange the, if you write the columns as rows, then the matrix will not change. If suppose, then you can call it as symmetrical matrix. How? I have a matrix A. This is the column 1. I am going to write this one as row 1, like root 3, 2, 3. The column 2 as row 2, 2 minus 1.5 minus 1. And the column 3 as row 3, 3 minus 1, 1. So again what you got? This is nothing but the same matrix. That's why here A dash is equals to A, or A transpose is equals to A. These type of matrices are known as symmetric matrices. Clear? Then what is skew symmetric matrix? Just see here. Skew symmetric if A dash is minus A. A square matrix is a skew symmetric if A dash is minus A. Find out the A dash for this particular matrix. I'm going to write the column as row. 0, minus 2, 3. Second column as second row. 2, 0, minus 5, minus 3, 5, 0. Okay, just observe here the first element is same. This one, all these are diagonal elements are same. They are 0. Here 2 we have, but here minus 2 we have. Here minus 3 we have, 3 we have. That's why we can tell here A dash as minus A. Okay, this is skew symmetric matrix. Then orthogonal matrix. What is orthogonal? You have a matrix, multiply the matrix with transpose of the matrix, and you are getting identity matrix, irrespective of order. Then that particular matrix, a square matrix, is known as orthogonal. Okay. And one more point here, you should remember that in skew symmetric matrix, if it is skew symmetric, the diagonal elements are 0, 0, 0, 0. Okay. Yes. Let us see some examples. Find the transpose of each of the following matrices. Okay. Let us find out. What we need to do, they have given a matrix. I'm taking the name as A, 5, 1 by 2, minus 1. I have a matrix here. And I wanted to write A transpose or A dash. I need to write the column as row. So I will get 5, 1 by 2, minus 1. This is the first question. And the second question is like this. We have some matrix P, 1, minus 1, 2, 3. This is a 2 by 2 matrix. We wanted to find out the transpose of the matrix. We will write the column as row. 1, 2, second column as second row. Minus 1, 3. This is P transpose. The next one is a 3 by 3 matrix. Let me take some M, matrix M. Minus 1, 5, 6, root 3, 5, 6, 2, 3, minus 1. What is the transpose for this matrix? M dash. We will write columns as rows. Okay. Minus 1, root 3, 2, second column as second row, 5, 5, 3, 6, 6, minus 1. Okay. This is a transpose of the third matrix. Okay, let us see next question. There is the question like this. They have given two matrices and we need to verify this particular thing. Verify the properties. Let us find out what is A plus B first of all. -1, 2, 3, 5, 7, 9, -2, 1, 1, plus -4, 1, -5, 1, 2, 0, 1, 3, 1. You wanted to find out A plus B. Add the corresponding elements. -1, -4 is -5. 2 plus 1 is 3. 3 minus 5 is -2. Like that, add all corresponding elements. 5 1 is 6. 7 2 is 9. 9 0 is 9. -2 1 is -1. 1 3 is 4. 1 1 is 2. No, you are not multiplying, you are adding. And for this entire matrix, we want the transpose. The question is left hand side, A plus B whole transpose. I am going to find A plus B transpose. Okay, what we need to do? Write the column as row. -5, 6, -1. Second column as second row. 3, 9, 4. Third column as third row. -2, 9, 2. This is A plus B whole transpose. Let me find out individually what is A transpose. We have A like this, -1, 2, 3, 5, 7, 9, -2, 1, 1. What is A transpose? A transpose is -1, 5, -2, 2, 7, 1, 3, 9, 1. This is A transpose. Find out B transpose also. We have B like this, -4, 1, -5, 1, 2, 0, 1, 3, 1. What we'll get here? B dash as -4, 1, 1, 1, 2, 3, -5, 0, 1. Okay. If you add these two, A dash plus B dash, A dash plus B dash, what we'll get? Add the corresponding elements. It is -5. 5 plus 1 is 6. Yes, you can see here. -2 plus 1 is -1. 2 plus 1 is 3. 7 plus 2 is 9. 1 plus 3 is 4. Like that. Here we have 3 minus 5. This one. -5 and 3 is -2. 9 plus 0 is 9. 1 plus 1 is 2. Now just observe this one. A plus B whole dash is nothing but A dash plus B dash. The same matrix. So you can conclude here A plus B whole dash is nothing but, whole dash is, you can call it as whole transpose also, no problem. A transpose plus B transpose. In the same way, you can check this second property also. In the same way, you can check the second property also. Okay. This is a small introduction about transpose of a matrix. Let us see one more example. A dash is that particular thing. B dash, B is that. Verify. Again, same properties. First, we should have what is the mother matrix. A. They have given A dash here. I am going to write A. 3, 4. Okay. Let me write the column as row. 3 minus 1, 0. 4, 2, 1. I got A value. Already B they have given clearly. -1, 2, 1, 1, 2, 3. A plus B, if you find out, A plus B, you will get 3 minus 1 is 2, -1 plus 2 is 1. 0 plus 1 is 1. 4 plus 1 is 5. 2 plus 2 is 4. 1 plus 3 is. And if you find out transpose for this particular matrix, it will be like 2, 1, 1, 5, 4, 4. Okay. This is A plus B whole transpose. Now, already they have given A transpose. So no problem. 3, 4, minus 1, 2, 0, 1. Let us find out B transpose. B transpose is minus 1, 2, 1, 1, 2, 3. If you add these two, addition, what you will get? 3 minus 1 is 2. Minus 1 plus 2 is 1. 1. 4 plus 1 is 5. 2 plus 2 is 4. 1 plus 3 is 4. Okay, this is our result. So we can conclude, you just see these two matrices. We can conclude A plus B whole transpose is nothing but A transpose plus B transpose. Okay. And they are asking here it is orthogonal or not. A dash whole dash is I. No? Okay. Let us see the first question. They have given A as cos alpha, sin alpha, minus sin alpha, cos alpha. If you find out A dash, what we'll get? Cos alpha, sin alpha, minus sin alpha, cos alpha. Both are 2 by 2 matrices only. Let us find out what is A dash A. What is A dash A? First we need to write A dash matrix. Cos alpha minus sin alpha, sin alpha, cos alpha. And the A is cos alpha sin alpha minus sin alpha cos alpha. How we will multiply? Row and column. Cos alpha into cos alpha, cos square alpha, minus sin alpha into minus sin alpha is plus sin square alpha. Cos alpha into sin alpha is cos alpha sin alpha. Minus sin alpha into cos alpha is minus sin alpha cos alpha. Second row, first column. Sin alpha into cos alpha is sin alpha cos alpha minus sin alpha cos alpha. Second row, second column. Sin alpha into sin alpha is sin square alpha. Cos alpha into cos alpha is cos square alpha. This brackets. We know that the basic identity sin square theta plus cos square theta is 1. So this is 1. These two are same terms. So they will become 0. These two are same terms with opposite sign. They will become 0. Sin square theta plus cos square theta is 1. This is our I identity matrix. So you can tell here A dash A is I. Okay, this is how we will find out the solution. If there is any doubt, just mention in the comment section. We will discuss on it. Thank you very much.